Before discussing about factorization, let's talk about zero factor property, which will help us in solving those equations. Okay, zero factor property means, let's suppose if we have two numbers, those two numbers could be either real or complex. So let's suppose A and B are two numbers, and if their product is equal to 0, then either A equals to 0 or B equals to 0, or both A, B equals 0. So you can just think of a real situation. Multiplying any two numbers, any two non-zero numbers won't give you 0. Okay, so that's why at least one of the numbers should be 0 or both should be 0. This will help us to solve the quadratic equations. Ax square plus bx plus c equals 0, where a is not equal to 0, can be solved in three main ways. One is by using factorization method that we have already discussed. Another is completing the square, and another is by using quadratic formula. Okay, so let us start to discuss about them stepwise. 1. Factorization. Let me take an example. We have already seen factorization while factoring the trinomial. X square plus x minus 6 equals 0. Let us factorize this. This is very simple. Okay, you multiply 1, the leading coefficient, with negative 6. So that's 1 times negative 6 equals negative 1 times 6. So 1 times negative 6 is negative 6. We would like to ignore this negative sign for now. Okay, let us prime factorize this 6, which can be written as 2 times 3. These are the only two factors of 6, and then we should add them in such a way that we will be getting the middle coefficient. So 3 and 2. If we go for 3 minus 2, we will be getting 1. Let us stick this negative 1 with 2, okay, such that we will have positive number. So negative 2 and 3 would be our factor. Okay, then x, since multiplication of leading coefficient with the constant is factored in this way, and these two factors, when we add them, will get us 1 in here. So that's why we can assure ourselves that we have two linear factors. Then we can simply plug in this value, negative 2 in here and 3 in here. Okay, so that's negative 2 and positive 3 equals 0. Thus we got our linear factors. Then by zero factor property, we can either write down either x minus 2 equals 0 or x plus 3 equals 0. So if you solve this equation, then x equals to 2 would be the solution, and x equals to negative 3 would be another solution. Another thing is that we need to check whether both of those are true or not. Okay, sometimes there might be special cases where one or both solutions may not be the true solution. Okay, so that's why we need to check whether these two are true or not. Check. For x equals to 2, we would have x square, so that's 2 square plus x is 2 minus 6 equals 0. So I have plugged in this value, x equals to 2, in this equation, and we don't know whether this is true or not. Okay, 2 square is 4 plus 2 minus 6, still don't know whether it is true or not. 4 plus 2 is 6, minus 6 is 0. 0 equals to 0, which is true. So this is correct solution. Now let us check x equals to negative 3, whether it is another true solution or not. Let's plug in this value in this equation. So that is negative 3 whole square plus negative 3 minus 6 equals 0. We are not sure whether this is true or not. Negative 3 square, that's 9, minus 3 minus 6. So 9 minus 9 is 0 equals 0. So this is also true. So we are quite happy that both of these solutions are true. But it may not be the case always. Okay? The second method that we are going to discuss to solve any quadratic equation is completing the square. This might be very handy for us, especially when we will be doing transformation of graphs. So completing the square means if we have quadratic equation ax square plus bx plus c equals 0 where a is non-zero, then completing the square means we want to write in this form, okay? A times x minus h whole square plus k equals 0, right? Where x minus h whole square is the square, perfect square, and k is a simply constant, okay? A comes from the leading coefficient, h and k are constants to be found, okay? What are h and k? h is simply negative b over 2a, where this b is the second coefficient and a is the leading coefficient, and k is just plug in this value h in the equation, okay, in the left side of the equation. So that would be a times h square plus b times h plus c. So that will give us the value of, let us do one problem. So example, x square plus 4x plus 1 equals 0. Here a is 1, b is 4, c equals to 1. If we compare this equation x square plus 4x plus 1 with ax square plus bx plus c, okay, then let us find h. H would be negative b over 2a, so that's negative b is 4 by 2a is 2 times 1, so that's negative 4 by 2 is negative 2, okay? So h is negative 2 and k is a h square, means a is 1, h square is negative 2 whole square plus b is 4 times h is negative 2 plus c is 1, 4 minus 8 plus 1, k equals 4 minus 8, 4 plus 1 is 5 minus 8 is negative 3. So h is negative 2, k is negative 3. Then the perfect square, a x minus h whole square plus k equals 0 becomes a is 1 times x minus h minus 2, okay, h is minus 2 whole square plus negative 3 equals 0. Now let us solve this equation. So this would be x plus 2 whole square. Let us add 3 on both sides, then this would be 3, okay? Let us take square roots on both sides, then this would be, then square root and square will be cancelled out. So that's x plus 2 in the left hand side and equals, we need to remember that whenever take square roots on both sides, then we need to add a positive negative sign in front of the square root 3, okay, in front of this number, okay? Why we are doing this is, since we know that this is a quadratic equation. Quadratic equation always has 2 roots, okay, and so this will give us the 2 roots. X equals, subtract negative 2 on both sides, so this will give us negative 2 plus minus root 3, okay? Thus our two solutions are x equals to negative 2 plus root 3 and x equals to negative 2 minus root 3. So these two are the two solutions for this quadratic equation by using the completing squares.